My name is Ye-Kyoung Kim, and the title of my presentation today is Integrating STEM Methodology with English Pedagogy on Synchronized Digital Platforms. For the brief introduction of the presentation, I have conducted and prepared introduction of my work. That is the basically students' web portfolio project, the project that students worked with me in my class. So in the class, I taught computer science class for undergraduate students for both non-STEM as well as STEM majors. So the classes were very diverse in terms of the general, in terms of the majors, also students' populations on campus. Okay, so I taught the class as an instructor, and also at the same time, I conducted research case study with my students in this blended STEM learning class. So this is a brief overview of the class that I taught in the class in the school years of 2004 and 2007. 2014 to 2017. So I have had enough opportunity to observe what students learn and how they work on the course curriculum and the course assignments for a long period of time. So this is the course descriptions. And basically the students are learning the world of the zeros and ones of the computer languages. At the same time, the communicating their learning process and outcomes in the language of English and other languages as well. So this is the course descriptions that students went through for 16 weeks over the 4 months course period. And at the end, students produced their web portfolio projects. So I have shortlisted here some samples of students' portfolio projects from diverse students' backgrounds, including, for example, here, let me show you. This is a student project who's working on the robotic programming.
Sorry to interrupt, but I'm not sure. On my screen, I've just got the first page, the introduction.
Oh,
still.
So you want to see it again?
I don't know. It doesn't seem to be going through to the next screens.
Oh, okay. Hold on. Okay, this is the introduction. And I included the students' work samples here. So I'm kind of demonstrating some of the examples right now. And this is the students in computer science. And this is a student who's working on assistive technology as a teacher, the in-service student teacher candidate. And this is the another candidate of computer science majors. And this is from the agriculture science majors. So students included the video project, as well as some the Microsoft Word project and PowerPoint presentations of their the class presentation project. And this is students, again, computer science major or the computer information systems majors work on the word processing technology. So included the video and some descriptions of the meaning of his project in the real world applications. So again, getting back to my PowerPoint. When I worked on this project, I had two distinct challenges. to work on this interdisciplinary approach to computer-assisted STEM and language learning. The first step was in the design and implementation of instructional materials and methods for abstract, non-STEM, and STEM courses and projects. The accurate and concrete representation and the structured and organized presentation of concepts information using cognitive principles are very important. And the second step was I had to the conduct and implemented and also analyze since web portfolio projects in a computer science experiment in the Pacific Islands. This study suggests the emerging research on cognitive process modeling and its a protocol that more reliably detects, tracks, and measures and communicates metacognitive instructional practices on synchronized digital platforms. And this study is basically based on the theory of distributed cognition. And in order for me to understand how I could interpret the two different disciplines of computer science integrated STEM projects teaching as well as the language teaching at the same time, I had to find some APACALL, the journal database systems. So I found about 50 to 70 different articles on this topic or the theme. So let me review just a few review of the framework of the theories or the conceptual backgrounds. This study is grounded on the general theory of distributed cognition, known as DC, that describes the operation of cognition, relates to students' learning processes, performance, and outcomes, distributed across the design, applications, and functions of instructional materials, tasks, projects, tools, and scaffolds, assisted with innovative technology, digital media, and cognitive principles. In particular, DC conceptualizes, facilitates a range of directions and pathways for the domains of inquiry and logical, analytical, and synthetic skills related to successful learning processes, performance, and outcomes. A review of DC literature engages not only educators, but also researchers in modes of critical inquiry on the dynamic relations between technology, instruction, cognition, and learning situated in a wide range of variety of instructional contexts worldwide and across aligned disciplines such as non-STEM and STEM fields. So this is the basic overview of my the theoretical or conceptual background of my project. Next one, again, I had to figure out how to integrate two seemingly different disciplines of STEM, including computer science, computer information systems majors work, and English or the digital English learning at the same time in the course processes throughout 4-month period. So I had a hypothesis or the question to answer throughout the semester or the past couple of years to work on this project. The question is, how do we integrate the STEM and digital English learning at the same time in the courses? So this is my framework of methodologies that I worked on together and analyze the data that I collected while I'm working on the project with my students. This study is a multi-year research that designs, implement instructional process modeling and its protocol that are appropriate for the ethnic minority students and the context based on the measures analysis of variables of ethnic cultures, demographic profiles, cognition, and academic performance. The students' learning outcomes are students' outcomes are personal competency-based productivity web portfolios that are available on the internet. This computer lab-based experiment was conducted while teaching a cohort of 110 undergraduate students who took an introductory computer science courses across 3 semesters. It was required for STEM majors and offered as a general education requirement course as well, representing students' populations at the university in the small Pacific Islands. The lab was still operated on 2000 Windows as well as 2007 Windows XP systems and its service packet. Information on students' participants' demographics was collected using a survey questionnaire on the first day of each semester to include the following 3 data sets. The students' ownership of personal computers and internet, 1. The students' prior knowledge and skills of computer hardware and software, 2. Other educational backgrounds, 3. For the project, a 7 series of multidimensional cognitive process modeling was designed with an emphasis on following or attending logical and analytical and synthetic skills related to successful course completion. This model was constructed based on the information on the students' cultural context and the instructional intervention module called the Cognitive Learning Intervention Program, simply CLIP. This CLIP instructional intervention model that entails and frames the 4 areas of inquiry on students' cognitive and academic skills. In addition, the Moodle online course learning management system was used to supplement a class taught mostly face-to-face in the computer lab in which various tools and resources were implemented to facilitate learning and communications, such as video lectures, PowerPoint presentations, handouts, announcements, discussion forums. Online web advisor also implemented for tracking dropouts and retention from the courses and posting grades online for students. The cognitive variables included not only higher order critical thinking processes, such as comprehension, interpretation, logical reasoning, analysis, synthesis, but also memory, working memory, deductive thinking skills, such as hypothesis testing and testing. The variables also included attention, creativity, and innovation. This is not the cognitive domains, but also included as measuring students' metacognitive abilities. The range of variables were required to influence cognitive in metacognitive functions in dealing with and completing a web portfolio project that innovative STEM fields demand. That is behavioral, linguistic, mathematical, and digital. So now, yes?
Just your last thought? Yes.
Okay, so this is the ways how I worked on this new approach of integrative STEM and learning instructional model. And this is how I collected data from students' populations, students participants in the courses that reflects the STEM curriculum content and also requires this, linguistic skills demonstration. So basically, the findings and the data analysis demonstrates students' skills in 7 domains: literacy, numeracy, and multimedia design. That is also called digital literacy. Also, how students combine and organize and construct their website user interface system for audience or viewers, and how they communicate this knowledge and technical STEM knowledge and skills for global communications on the internet. So based on the the research work with the students. The case study found some main findings. In this presentation, I just included one main thing related to language teaching in
We
our
just have,
community,
yes,
which is that,